All right, hopefully final installment of section 9.3, but this is the real deal, um, full pull kind of culmination of what we want you to be able to do from this section. Everything's been built to this point. So let's map this thing out. We're trying to use our calculator. Not at all. All right, so we're going to try to find negative 240. Not at all. So negative tells me I'm going all the way around this, but there's 180, so I'm guessing I go another 60 to get to 240. Then my triangle is here. So there's a couple things I'm going to write right away. My reference angle is 60, right angle. Next thing I'm going to write is this memory mnemonic, right? So from there, if we come out with a unit circle perspective and know that this is negative 1 comma 0, and we want to evaluate this, and we know this is negative 1, right? And then we know the side opposite of 60. Well, let's just do it this way, right? Because we've already justified it in the last video, and you can refer back to that last video. We know that's 30. So we know that this side is 1 long overall, that this ends up being the square root of 3, and this ends up being 2. Yeah? So from there, what we do is tan is, let's see, toa. So we go tan is opposite over adjacent. So we're going to say square root of 3 over 1. So that's a lot of the main work. But now the last thing we got to look at is all seniors turn crazy. In quadrant 2, where we're drawing this thing, the only trig function that comes out positive is sine, which means tangent should come out negative in this case. So we're going to say the answer here is negative square root of 3. Now, to check myself, I'm going to go to my calculator just to type this in and see what we get. So, believe it or not, I type in my calculator tan of negative 240. If you can do it too on your calculator. So basically, I'm saying this. Did we do this right? Right? And I get negative 1.732 and change on this side. And then when I type this in, our answer, I also get, which is very satisfying in terms of the fact that we did it right. So let's go on to the next. It occurs to me that I should have told you right away that we're going to be messing with these special right triangles every time we do this. So let's try again, right? So we go negative 180, and then we still got another 30 to go. So it would appear to me that our triangle will be in the third quadrant. This will be 30, which makes this 60, and this 90. So now we draw in the special right triangle, right? This would have to be 1. This would have to be square root of 3, and this would have to be 2. Now we go to cosine. Cosine adjacent of our, so here's our reference angle, adjacent over hypotenuse. And then I also look at that all seniors turn crazy in the second quadrant, only sine is positive. So this thing's probably equal to negative square root of 3 over 2. Again, just to make sure, I'm going to go cosine of negative 210 in my calculator and get negative 0.866. And then I'm going to do negative square root of 3 divided by 2. So the answer I'm going to want from you on a quiz is this radical fraction. I will not accept the decimal because anybody can do that with their calculator, right? But you can use your calculator to check and see the decimal values, see that they're on the same rhythm. Okay. Now, let's see with this, because now we're messing with radians, right? So if this is 0 and this is pi over 2, this is pi, this is 3 pi over 2 from previous sections, and this goes back to 2 pi. The biggest thing I see right away is that this is over 6. So for my brain to not hurt so bad, pi over 2 is equal to 3 pi over 6. Simple fractions, right? This is equal to 6 pi over 6. This is equal to 9 pi over 6. And this is equal to 12 pi over 6. So when I see 17 pi over 6, I know I'm going all the way around. That's 12, right? Which still leaves me with 5 pi over 6. So I go another 3 pi over 6. That must mean that I am in quadrant 2. And I'm at, let's see what I say. If I go 12 pi and 3 pi is 15 pi, this must be 2 pi over 6 is my reference angle, which can, of course, be simplified down to pi over 3. Pi over 3. Say I'm having trouble messing in these radians or visualizing, because now all of a sudden pi over 3, what special right triangle goes with pi over 3? Well, then why don't we just do the math of putting this back into degrees? So pi over, gosh dang it, pi over 3 times 180 over pi. Cancel the pi's. 180 divided by 3 is 60. So really I can think of my reference angle as 60 here if degrees help better. So 60, we got 1 for a side, we got a square root of 3 for a side, and we got 2 for a side. Cosecant is, so if sine is opposite over hypotenuse, cosecant of a reference angle is the opposite, hypotenuse over opposite. So when we go to our reference angle of 60, we go hypotenuse 2 over opposite square root of 3. In the second quadrant, sine is positive, which also means cosecant is positive. These two are paired together, right? So we don't need to change the sign. The final thing I'm concerned with is rationalizing the denominator. So I go like that, and I would get 2 root 3 over 3. The only answer I would accept for this problem. Anything else is trending into using technology too much in your head, not enough. So I guess here in 4, secant is the opposite of cosine. We'll identify that. We'll also take radians and put them into degrees so that we can mess with degrees that don't hurt our brain. Divide top and bottom by 4. 45. So apparently 11 pi over 4 is equal to 495 degrees. Now I go all the way around the circle. Once I'm at 360. Now I'm at 135. I go 90 degrees past the first quadrant. And I'm going an additional 45 to get to 135. So then I do 180 minus that 45 I just traveled past. Not 180, 90 minus the 45. And I got 45 for a reference angle. If I just made that clear as mud, make sure you call me around to your desk to re-explain how I know that's a 45, 45, 90 right triangle. So if we draw in references of 1 and 1, square root of 2, which we would have had before, we can now go through the math of getting our final answer. So cosine is adjacent over hypotenuse, which means secant over is hypotenuse over adjacent. So we were looking at square root of 2 over 1, which is square root of 2. Issue being in the second quadrant, only derivatives of sine are positive, so our final answer needs to throw a negative on there. If I go into my calculator and I do the secant of 495, I get something like negative 1.414. If I type in negative square root of 2, I also get negative 1.414. So that's just verifying that this is the answer I want. This is the answer I accept. This will be real deal math that you need to devote yourself to getting done in your brain, whatever. If you need me to do a whole class lesson live, just say so.